Andiamo. Hi everyone, good evening and welcome to this session of the 2021 Download Innovation, and specifically, can you hear me? Give me some kind of feedback, please. Hi guys, can you hear me? Hello? Okay, perfect. So I'm Maurizio Velluti. I will present in this session the next generation maintenance services. I have about 30 years of experience in IT, and I'm in Sorint since February this year, and I hope to contribute to Sorint's success. So I asked the director stage to start and to switch to the presentation, please. Okay, so first of all, a brief agenda of what we are going to present. We'll talk about the circle maintenance or Sorint.LAB. Then we will present the traditional approach, some slides with the traditional hardware maintenance approach. Then we will present the next generation approach, and we'll start to introduce what is called digital prescriptive maintenance. And then we will give a practical implementation model. And the last slide is related to suggested readings. So, as I said earlier, I have about 30 years of experience of IT management, international experience in leading distributed teams, delivering services and contracts to customer. I worked for multinational companies, but also for local companies, and now I'm in Sorint. My circle manages the whole life cycle of hardware maintenance and user and ITIL services and projects for our customers. Let's start talking about which are the services that my circle is currently implementing or starting to implement. First of all, which is the vision. The vision we have is to leverage on strategic partners to fully exploit Sorint.LAB capabilities and grow the business through cross-selling. You know, sometimes you start providing services from the low level of the stack, and then you can propose all the higher level services. So even if you enter a customer only with hardware maintenance, then you can progress and you can broaden your presence by the customer. Specifically, we provide 3 pillars. We provide hardware maintenance services. We provide flexible workplace, previously called end user services, but now it's nice to call this kind of services flexible workplace. And all these services are provided through IT processes, through ITIL processes, so incident management, asset management, and so on. Some of these services are ready. We are ready to provide the services. Some are in our roadmap. So normally, which is the approach we use when we provide this kind of services? We have an articulated team with a central component, a local component, and a territory component. For the central component, we have all the shared services and teams that are functional to the provision of the service. So starting from the customer interface, the service governance, or the service delivery manager, or the project manager in case of projects, the logistics and staging, the procurement, then the service desk and monitoring platform we use to provide this kind of services. And this is the central team. Then we have a local team or local teams providing services by the customer on-prem, on our customer premises. And typically these are Sorint people that act by our customers, and people that know very well the customer infrastructure, the customer organization, the customer problems, the customer roadmaps, and so on. And we have then a territory team, and typically this team will leverage on partnerships to provide distributed services. And we have at the moment important partnerships, but we are trying to grow in terms of opportunities and in terms of volumes that we can provide to our customers. Which are the differentiating factors that normally characterize these kind of services? These are common to all maintenance service provider, let me say, but not every service provider is capable of having this, in reality, these differentiating factors. First of all, the widespread coverage of the whole national territory. Italy is not easy to manage for the geographical shape of the country, but also for the infrastructures. Reach some small sites is very difficult. So it's difficult to have the full coverage of the territory. And specifically, if we must comply, we must respect SLA, because sometimes our contracts have very stringent SLAs. Then another factor is the full availability of multi-vendor spare parts. Then the smart logistic capabilities, obviously the technical and quality certifications, the ability of our people and also of our partners, the ability to implement ITIL processes, the ability to implement the full stack of IT services. And Sorint does have all these capabilities and the capability of implementing all the stacks, starting from low and going high. Then we have a 24/7 per 365 service monitoring and governance capability. And currently we have this capability through NGMS. And we could also think of broadening this kind of capability through the implementation of service desks, for example. Then we have lean support processes and the flexible people capacity and staffing. These are the differentiating factors that we have fully or partially and that we must improve. And which are the elements that are under these differentiating factors that we must have? The element for success are the capability of managing different core management systems and knowledge management databases. Obviously, having our people trained and certified on the major vendors and on our customer infrastructures, the service monitoring and SLA quality assurance through our service delivery managers, having smart logistics processes in order to adapt ourselves to our customer requests that can be variable, having qualified staffing capabilities. So when we look for a technician or we look for competencies, specific competencies, be able and fast in finding capabilities, or internally or also externally by our partners. Then we must grow and develop strategic partnerships, not only with other vendors, but also with cloud and data center providers. We have to develop partnerships with logistics providers, and also towards our customers, we must improve the technical and marketing presentations and labs to support pre-sales and sales, to have more opportunities. Then our pre-sales activities must be aligned with operations in order to be sure that what we propose is what we can really do and what we do better. And then to have an alignment on regular updates of customer lists, prospects, and pipeline. But this approach, all we representing, has some drawbacks, because this approach is the classical approach, and it's mostly a reactive approach. We wait till a given piece of equipment fails. So we do nothing normally till this asset fails. At the end, we have higher costs in the medium to long period, unexpected downtimes for customers, slowdown of critical facility processes. We have SLA breaches and lower quality services, loss of revenue and reputation for the customer, but also for us sometimes. We have labor and spare components costs not accurately forecasted. And we have, at the end, a reduced safety of our customers' infrastructure, lowered life expectancy of assets, and poor time management of employees. And our colleagues and our engineers are bound to act under pressure and have to take more risks to get a job done quickly, and at the end they can become disengaged. So at this stage, I would like to ask you a question, and you can use the chat. Even if I look the chat and I see very small, but I try to catch your questions. What can we do to drastically change the situation and better the situation and improve our services, our customer experience? What can we do? There is someone that wants to give some advice in the chat. You can write in. You can write on the chat. Someone out there? Some ideas? Okay, no ideas? A feedback? To be not afraid. What does it mean? Not afraid of what? Some let me say, okay, keep the change and go on. Okay, something more technical. Till now, I've shown things that are technical, okay, but not so much. I haven't talked about specific certification, specific hardware. What do you think we could introduce? The first step can introduce to improve dramatically the situation. I was talking about reaction, so to be reactive. Okay, if you agree, I can go on, okay? And I think that the first step would be, for the next generation approach, to introduce predictivity. So, what is predictivity? If you consider that an asset is a thing, an item, or an entity that normally is part of the physical infrastructure of our customer, and this asset has an actual or potential value, when this asset breaks, there is a problem for a customer. Consider that in the asset management practice, predictive maintenance is the third stage. The first stage is reactive maintenance. So we wait till an asset breaks and then we act. We have also the second stage is preventative maintenance. So we can have a periodic maintenance activities on some assets in order to prevent faults. But this practice sometimes is effective, sometimes it's not, and introduces higher costs. The third stage is predictive maintenance. So the idea is to make repairs in advance. So to have information, to gather information from assets that can help us indicate that a failure is imminent. So will happen soon. So predictive maintenance is a new practice that is growing and comes from asset information. Some years ago, we had few information about assets, and now we have much more information coming from data gathered through instrumented and connected assets, through IoT, Internet of Things, to the convergence of IT with the operational technology, through the advances in analytics to gain insights from data. Because if you have a lot of data, you must have also the capability of analyzing this data. And with artificial intelligence technologies, such as machine learning, for example. What this process, this predictive process, has as a characteristic, the main characteristic. The main characteristic is, first of all, is data collection. So we must be able to collect data from our assets. And secondly, to have an improving cycle. So the identification of a baseline about breaches, the creation of work order in order to fix these breaches, the execution of maintenance, and then the repetition and the feedback to improve the baseline. So to identify more useful predictions. Which are the advantages? The advantages of predictive maintenance approach. First of all, that we are anticipating faults, so this avoid downtime and improve productivity for our customers. This extends the life of an assets and defer new purchases, so we better manage the customer assets. We reduce the cost and complexity of repairs. We mitigate additional or related damage to the customer infrastructure. This helps us to meet regulatory standards for our customers, for example, for dismissal of old assets and compliance. Helps us in managing better spare parts, materials, and inventory. And at the end, this helps to boost the bottom line, so reduce the overall cost of ownership of the service. What is needed to implement predictive maintenance? First of all, what is needed is the integration of hardware and software. So we must collect and gather information from hardware, and to avoid siloed information. So to gather information, and this typically can be done with market products, but also developing some kind of software internally. Then we must include Internet of Things, so the information gathered through Internet of Things. We must identify risks connected to the faults, and we must also decide which are the best management strategies for these faults. We must put focus on reliability and efficiency for the customer infrastructure, and this is achieved creating statistically valid models about faults. And above all, we must have the ability to gather data, but also to analyze data in order to extract from the big data we have available the meaning of data. So not the meaningful, but the quality data we have in our overall data available. So, what could we do to improve further the situation? You can write on the chat again if you want. So we were moving from reaction to prediction. And now what we can do to make a step further? Don't be shy. Write on the chat, please. Even if you have funny ideas. No ideas? Okay, if you give me okay, I can go on. You still hear me? Okay, I will go on. So, the topic is digital prescriptive maintenance. So, what can we do to go beyond prediction? Which, if we consider the reactive approach and the predictive approach. The predictive approach answers to this question: what will happen and when? But this approach doesn't tell us what should I do to make something happen. So the prescriptive maintenance is the link between prediction and operation and management. So we have two main processes, two main iterative processes in prescriptive maintenance, and the first one is exploitation. So we must search, retrieve, and provide and using existing knowledge in order to perform our maintenance activities. But the next one, and the most important, is exploration. Exploration is to increase our knowledge. So not only using the knowledge we have from the past, but also identifying and increasing our knowledge through the discovery of new correlations between data, between static but also, and importance, this is important, streamlined data. So current data that must help us to explore new knowledge. So to make a sentence, prescriptive maintenance is the missing link between predictive approaches and maintenance planning strategies and decision making. So in terms of complexity and in terms of maturity, we were talking about descriptive maintenance, so reactive approach, diagnostic maintenance, so second stage, to answer to the question why something did happen, not only what happened, which is the reactive approach, but why did it happen? And this is the classical approach, let me say. The future approach will be the predictive maintenance, so what will happen and when, but also and above all the prescriptive maintenance, so to answer how should a specific event happen. So not only to have the prediction of when something will happen, but also what should I do to make something happen. In these advanced approaches, we have some elements, distinctive elements. One is automation, so automation of maintenance workflow. The other one is sophisticated data analytics. And we have not only the complexity level increasing, but also the maturity level increasing. When we talk about KDM, it's simply knowledge-based maintenance. So maintenance based on knowledge, maintenance based on information that becomes knowledge. What do we need to implement prescriptive maintenance? We must leverage on essentially three digitization forces. Internet of Things, big data analytics, and dynamic case management. What do you think? What is dynamic case management? You have some idea? The case is the classical incident we have. So something breaks, I open an incident, and then more or less I know how to manage the incident. I log the call, I raise the call, I send an engineer, I create a work order. So dynamic case management is the ITIL process of incident management, but with some additional elements. First of all, dynamic case management is putting together predetermined repetitive process fragments with ad hoc and unplanned tasks. This is due to the fact that our information and our knowledge is not limited to existing information and knowledge, but also to the information we are able to gather through IoT, big data, and so on. Which are the key capabilities of dynamic case management? First of all, the digitization of value chain stages. So for end-to-end maintenance, we have different stages, and we must be able to digitalize these stages. Then the second one is putting together planned and ad hoc tasks. So planned and unplanned tasks. Then to introduce elements for the decision management. And this is lacking in the predictive maintenance, but is in the prescriptive maintenance. Then to be able to build efficient and effective predictive models. And then to be able to have the just-in-time integration of data flow with enterprise application in order to create work orders, in order to perform automatic optimizations, and so on. So, up to this point, we were discussing about the traditional approach, so reactive maintenance, the first stage evolution, so the predictive maintenance, and the prescriptive maintenance. So let us try to summarize the key concepts we were talking in the previous slides. So first of all, the process of prescriptive maintenance, it consists in operationalizing what should be done while leveraging the various types of digital technologies that we have and the data we can gather. Secondly, we can predict future events and diagnose potential problems before they occur. So we are not waiting for faults. Thirdly, machines will predict potential failures and can trigger maintenance autonomously. So with this triggering, maintenance cases can be created automatically and tasks can be assigned to things or people. Very important, which is the consequence of these actions and these capabilities, is to be able to fix the problem the first time. If we need to send an engineer on customer premises, our engineer will have all the information in advance, all the right parts and all the right procedures in order to fix the problem the first time. So avoiding duplicated on-site visits and so on. Another important aspect is that the case data can be audited and mined for subsequent knowledge management. Our knowledge-based maintenance is based on knowledge. So once we implement our service and when through the time, we gather more information, we extract more knowledge from this information, and we can change and improve our baseline or our prescriptive actions. Other key concepts are that the machines can become self-learning and over time can take care of themselves. Then we have a greater flexibility because we can have structured, semi-structured, and also ad hoc tasks. Everyone in the value chain and also the customer can have a view into the stages and steps of the process from end to end. And this provides a virtual cycle of continuous improvement. At the end, our processes are no longer static, but are dynamic and can be optimized through time. And at the end, all these features and all these capabilities can improve operational times, quality, productivity, and so on, and the customer experience. And then the work can be automated, monitored, and optimized. So, last question. Don't worry, this is only the last question. What do we need to implement the previous concept? Some ideas? So these concepts are really nice to hear, nice to understand, but what must we do in practice to implement these ideas? Some hints? No ideas? So first of all, we should ask us three main questions. The first question, these questions are the current questions that researchers and academic people are putting on the table in order to create models for the implementation of prescriptive maintenance. First of all, the first question is, which tasks and objectives should an efficient prescriptive maintenance comprise? Then, secondly, which data science methods are most suitable for predicting future events and how can they be integrated into a prescriptive maintenance process? Thirdly, maybe this is the most important question, how can the prescriptive maintenance maturity level can be assessed, including operational and management parameters? Because the first question is more technical. It is about tasks and objectives. The second is about data science methods, which is the software we could use in order to create a prescriptive maintenance integrated process. The third question is, which is the maturity level to start with when we have in front of us the customer. So to implement prescriptive maintenance, there are 4 dimensions we have to take care. The first one is knowledge-based maintenance, capabilities and models. Second is the decision support models, in order to create decision models to take decision. The third are data science methods, and the fourth is the maturity assessment framework. We will try to talk briefly about these 4, and we are coming to the end of the presentation. At the end, I will present a model that was built 2 or 3 years ago in an Austrian university, and is currently under practical implementation. So, which are the knowledge-based maintenance capabilities? KBM has 5 major functional capabilities: the prediction capability, the optimization capability, the adaptation capability to conform to unexpected changes, the learnability, so to continuously improve knowledge from experience, and the capability of intelligent actions and self-direction, so the capability of taking decision. There are 2 key aspects about functional capabilities that we have to take into consideration. Firstly, when we have a practical opportunity, we have to properly identify the functional capabilities. Secondly, we have to perform an optimal selection of the features aligned with the maturity level of the customer. So, to try to give a visual picture about the information we will have to manage, we have information mainly technical, so system conditions. We have the consequences that a fault can have on the customer infrastructure, but also on our activities. And then we have the management actions, so the decision that we have to take and the successive action we will have to take. The information related to systems, so technical information, are normally fed into a reliability center maintenance database or conditional and time-based maintenance database. So these are mainly technical information about past history, about faults, about the way we were getting to the fault. Consequences can be operational, so about efficiency, damages, degradation of performance, or financial, so costs, direct or indirect. And these consequences must be fed into a risk-based maintenance database. So in order to correlate the consequences with the risks the customer can have. And thirdly, we have a management, so the processes and the decisions that normally can be fed into different kind of databases and different kind of approach. For example, TPM, TLC, so an approach based on the cost, life cycle cost, and lean maintenance. All this information about system conditions, about consequences, about management and decision are fed into the KBM database. And there are the methods. So we have a shift between a rule-based method to a data-driven approach. So we don't have a fixed set of procedures, but we have flexible procedures. So we have methods that are based on machine learning, on deep learning, on anomaly detection, and on active learning. All these kind of methods can be found in the academic literature, and if someone of you wants to go deeply into the matter, at the end of this presentation I will give you some suggested readings. All these methods have something in common, the concept of feedback. So feeding back information about the outcome in order to optimize the overall process. Just a couple of words related to the KPIs. The KPIs for prescriptive maintenance are in two dimensions. So we have the maintenance dimension and we have the data analytic dimension. And for the maintenance dimension, we have maintainability, reliability of assets, availability of assets, repair times and downtime, and the cost of human resource effectiveness. And for the data analytics dimension, we have the data quality metrics, the accuracy of failure patterns for predictions, and the certainty or reliability of predictions. These are all our key performance indicators that we must take into account to develop an improvement process. Then we have the maturity assessment that fundamentally consists in setting up a baseline about the target assets that we have to manage, and then to develop the current prescriptive strategy, assessing the maturity level of the customer, and then setting up the new target, so improving the maintenance strategy for the customer. So just the last few slides in order to present the primal model. The primal model is the first model that was developed a couple of years ago in order to take a systematic approach for the development of prescriptive maintenance systems. So we have fundamentally a three-layer approach and 5 stages. For each stage, we will analyze the objectives of the service, the challenges, and the machine learning methods and the IT infrastructures needed. So we have 5 stages. The first one, before going to the stages, we consider that also this approach is a cyclic approach, starting from building a reaction model, then setting up a prescriptive decision support system, and then performing data acquisition and pre-processing, and then data analysis and simulation. First stage is to perform analysis and diagnosis. So building up the databases containing the information in order to facilitate the derivation and description of patterns in stored data sets, which can indicate a failure. The second stage is to build the prediction model. So future machine failures are predicted based on the previously derived failure patterns and incoming data sets in order to determine their probability of occurrence. The third stage is the setup of the decision support model. So the systematic prioritization and prescription of maintenance activities. So what will we do in case of a prediction of a failure? The first step is the planning of the maintenance operation, so the creation of the work order within the company's maintenance management system. And the last stage is the execution and the documentation of what has been executed, in order then to feed back the process and to start again the loop. So our time is over, and I have the last slide that tries to give you the overall architecture of the Prima model, so you can see in the lower part the data. So the data warehouse containing process data, product data, and machine data, and also the data necessary for the preparation of the work orders. These data are fed into a predictive layer. The predictive layer is a toolbox containing information about the probability, the analysis we make about probability-based methods, error-based analysis, and so on. And these information are aggregated and comes to the dashboard of the maintenance manager that has to confirm the decisions and also exchange information with the learning layer that is usually based on software that is specifically developed. And this learning layer is fed also into the recommender and decision support dashboard. Once the work order has been created, before issuing this work order and implementing and executing this work order, the maintenance manager has to confirm that the activity is necessary. And once the activity is performed, there is a feedback about the reliability of this prescriptive action. So this was the last slide. And for people that want to go deep into the detail, I can suggest 5 articles. These are academic articles. The first and the second are related to the reference model, to the Prima model. The third talks about dynamic case management, so it's more about processes. The fourth one is about big data analytics, and it's more about machine learning. And the fifth one is about the overall process of digital predictive maintenance. So the time is over, but if you have some question, presentation is ended, so we can switch. Okay. So if you have some questions, you can use the chat. I'm keen to get in contact with you in order to go deeply into these subjects. I know that there are at least one other speech in this download that specifically consider the argument and of predictions. Maybe it's more data focused, and that's it. So if there is some question, I can try to answer. Otherwise, we can end the session and hope that this short presentation has given to you the right messages, and that some one of you can go deep into these topics. Do you have some questions? No? Okay, so we can close this session and follow the next session of these downloads. Good evening to everyone.